What's that I hear? You want to learn yet another way of factoring polynomials? I can satisfy all your desires. Here's the essential question for today. So we learned synthetic division in class, and I was kind of like, we can use it to help factor, but how? How are we going to use this weird thing to help us factor? So, example 1, what are the zeros of this monstrosity? Now, first of all, in order to factor using synthetic division, we need to know what 1, 0 is already. And if I had more time on this chapter, we might talk about how we could figure those things out by guessing. But just imagine for now, you took a peek at the graph and it seemed like clearly 1, 0 was 2. And you want to know how to find the other zeros. That's going to help us because we can synthetically divide it out first. But first, let me justify us not being able to use any other method. Hopefully you're seeing that this is a 4-term polynomial, which might make you think, hey, let's use grouping. But take a look at what happens when we group. When I group the first 2 terms and pull out the GCF, that leaves me with x minus 5. I think the GCF of the second 2 terms is 2. That leaves me with 11x minus, what would that be, 28, I believe. Now, are these going to be able to factor out? Because remember, with grouping, we need those things to be exactly the same, and they're not here. So this one doesn't work with grouping. And I know in the textbook, every problem you've done that has 4 terms has worked with grouping, but that's because it's a textbook, and they're giving you kind of like the perfect examples. Many times, things will not work by grouping, and so we need to synthetically divide out. Now, first of all, let's think about this. If I know that a 0 is 2, let's think about the factor that gives us 2. That factor would be x minus 2. So if we factor and we see in the equation that I have an x minus 2, so let's say I factored something and I found that it was x minus 2 times x minus 3 equals 0, I would know, hey, a 0 is 2. So that's what I'm talking about here. A 0 of 2 is given by a factor of x minus 2. What we can do is we can synthetically divide out that factor. Remember, to set up your synthetic division, you put the opposite of what the factor is in this little prison thing up here. And if you're wondering why you do the opposite, maybe now you know, like you're really putting the 0 up here. That's what you're doing. Next, I'm going to grab the coefficients from my polynomial. So 1, negative 5, negative 22, and 56. And here's where the fun comes in. I think synthetic division is fun. It is super easy and nice, especially compared to the other kind of dividing that I could have taught you. Remember that the key is you first bring down the first factor. Next, you're going to multiply diagonally by 2. So 1 times 2 is 2. Now you're going to add down, so negative 3, and then repeat the process. So multiply diagonally by 2, that gives me negative 6. Add down, that gives me negative 28. And multiply diagonally by 2, that gives me negative 56, which, when I add down, gives me 0. And this 0 is very, very important because if you remember, this 0 is the remainder. So what I just proved is this factor divides out perfectly. And that's very, very important to us because think about how multiplication works. Let's say I divided 4 out of 12. Well, 4 divided by 12 is 3. Can't I then go and say that 4 times 3 is equal to 12? Because 3 has no remainder. So I can say, hey, this multiplies perfectly. 4 times 3 is 12. That's what I'm going to do here. Check this out. If you remember, the polynomial that I came up with is, here's the constant term, here's the x squared. I know that this thing, this big long thing, factors to x minus 2 times x squared minus 3x minus 28. And the reason I can say that is the same reason I can say this. Since I divided out x minus 2 and got this answer, I know that if I were to multiply x minus 2 times that answer, I would get the original starting problem, because division is the opposite of multiplication. And since I had no remainder, it worked out perfectly. So look, I just factored. I factored out an x minus 2, and I was left with this quadratic. Now we can go on and factor the next step. So, x minus 2 I have already factored out. Now I just have a quadratic. I can forget that I even did the synthetic division and just think about factoring the quadratic. That'll factor to x minus 7 and x plus 4. Yep, that multiplies to 28 and adds to negative 3. Keep in mind, since we're looking for zeros, the y would need to be equal to 0. That gives me the zeros of 2, which I already knew about, 7, which is new, and negative 4, which is also new. Now, that's pretty cool. Let's do a couple more examples so you kind of get used to the steps here, and I'll continue to provide the justification along the way. So example 2, what are the zeros of this? Now, again, I don't see any way that I can factor this at all. There is there's absolutely, well, now I can't go back. Little difficulties there, but I'm back. Okay, we're looking for zeros. I can't factor this at all. There is no GCF to pull out, which means that I can't really factor this at all. Even though there are 3 terms, it's clearly not a quadratic, and so I can't do anything with it. Thankfully, maybe we looked at the graph, we know one of the zeros is 3. And remember, the factor that gives that 0 would be x minus 3. And I can synthetically divide out this x minus 3. Remember the steps. I'm putting the opposite of this, or the 0, up in the house. So positive 3, not negative 3. It's the 0 or it's the opposite of the factor. I need to pull the coefficients, but let's be careful. I have 2. I have negative 7. I don't have an x term, so there's a 0x here. Don't forget the 0. Many people will forget the 0. Don't be one of those people. And then I finish with a 9. Remember, synthetic division is fun and easy. First, bring down the 2, then multiply it diagonally by what's in the house. So 2 times 3 is 6. Add down, negative 1. Multiply diagonally by 3, negative 3. Add down. Multiply diagonally by 3, negative 9, and look, there's that all-important remainder of 0. The remainder of 0 tells me that I've done something correctly because it tells me, hey, this actually is a factor. It divides out evenly. If you're trying to divide a factor out and you get something other than 0, you've done something wrong, because the whole definition of a factor is that it divides out evenly. Anyway, the point is, this was our remainder. Here's the constant term, here's my x, and here's my x squared term, which means since I divided x minus 3 out and got this, if I multiply x minus 3 times this new quadratic that I got, I will get my original problem. So I factored out an x minus 3. Here's another parallel, just if you're not totally sold on this. Isn't it true that when you make a factor tree, you're kind of dividing, right? So 8 breaks down to 4 and 2, and then 4 breaks out down to 2 and 2. So I can say, hey, 8 is 2 times 2 times 2. That's exactly what I'm doing here, just with polynomials. I divided out an x minus 3, so I can say, hey, x minus 3 times the result of the division is equal to the original. Pretty cool, so I factored. Now, as with last problem, I have already pulled out the x minus 3, and I'm left with a fun little quadratic to factor. Hopefully you remember how to factor when there is a non-1 coefficient at the beginning. Remember, it's not just multiply to this and add to this. It's more complicated. I need to think, what multiplies to 2x squared? Well, that's going to be 2x and x. What multiplies to negative 3? Well, it's only going to be negative 3 and 1, but I need to remember to get them in the right order. So check this out. If I FOIL, yes, 2x squared. Yes, minus 3. But do the middle terms check out? Here, I have negative 6x. Here, I have 1x. Do 1x and negative 6x combine to negative x? No, they don't. That means that the 3 and the 1 are in the wrong order. Let's switch them. Now I have negative 2x and positive 3x. Does that combine to negative 1? Well, actually it combines to positive 1. So I need to make one last switch. If I get exactly the negative, I can just switch the signs. Now I have a negative 3 and a positive 2, and that ends up correctly. So I have completely factored this quadratic, and really I've completely factored the polynomial. And I'm setting it equal to 0 because I'm looking for the zeros. Here, x equals 3. Here, okay, let's solve this real quick. 2x minus 3 is equal to 0. I would add 3 to the other side, and I would divide by 2. All right, so 3 halves over here, x would be negative 1. There are my 3 factors. Very nice. Now, the video is getting a little bit long. If you understood these two examples, maybe you get the point, but I want to do one more complex example, and I'm going to go through things really, really quick here. So, okay, factor of x minus 1, because the 0 is 1. I'm dividing this factor out, so pull out the coefficients. Don't forget that there is a 0x squared. And do the synthetic division really fast. If you don't remember how to do synthetic division, you can look back on the last couple slides. Oh look, I ended up at the remainder of 0. Nice. So that means x minus 1 times 4x squared plus 4x minus 16 equals 0. This factored to this. Now, there's a GCF I can pull out of the quadratic. I can pull out a 4. Let's put that 4 all the way at the front because I can multiply things in any order, so that's legit. If I pull the 4 out of this quadratic, I'm left with x squared plus x minus 4 equals 0. Now, here's the issue. I know that this results in a 0 of 1, but I need to find the zeros from here. Can I factor that? Well, since there's a lead coefficient of 1, I'm looking for things that multiply to negative 4 and add to 1. Nothing does that. So does that mean there are no zeros because this can't factor? No, even though it can't factor, I still know how to solve quadratics. Do you remember the quadratic formula? Negative b plus or minus square root b squared minus 4ac all over 2a. I already know the factor from this factor is 1, but to find the factor from the quadratic, I can plug things in to the quadratic formula. So let's plug things in. My b is 1, so negative 1 plus or minus 1 squared minus 4 times 1, because a is 1, times c, where am I going? Which is negative 4. Finally, a is 1. Let's simplify some things real quick. I have negative 1 plus or minus. Underneath the square root, I'm going to have 17, and on the bottom I have 2. Here are my other two factors. These really are real factors, but they're complicated. They are irrational numbers. There's no way to simplify this. So I have my 3 factors. Count them with me. 1 from the easy one, and then the plus would be the second factor. The minus would be the third factor. Sometimes you will have a quadratic that does not factor, and you can still use the quadratic formula to figure out the zeros. So hopefully that jogs your memory on those things. All right, I flew through that last example. Go back, pause, and rewind if you didn't get what I was doing. But basically, I used the quadratic formula to solve that final quadratic because I didn't know how to factor it. Summary: if we know a 0, we can begin by synthetically dividing out, I should say, the factor that gives that 0. I messed up those words. So you're dividing out the factor that gives the 0 that you already know. Then all we have to do is factor the remaining quadratic. Typically we will be able to factor it, but sometimes we can use things like the quadratic formula. And then we're done. We'll have our multiple roots. Thank you for watching, and take care.